Well, I already know that iridium has a very high melting point. It's about 2400 Celsius, is that correct?
You're close, Commander. Iridium's melting point is actually 2446 degrees Celsius, just a little hotter.
Okay, so it's used in the spark plugs of high-performance aircraft, the leading edges of some high-performance aircraft as well. It's used in the gyroscopes of rocket ships, sometimes also the nozzles because of all the nasty chemicals and heat. It's used in stents and pacemakers, the nibs of fountain pens, some medical devices. These certain things I'm aware of.
You've covered a lot of the basics there, Commander. Iridium's high melting point and durability make it perfect for those kinds of applications. It's also resistant to corrosion, which comes in handy for things like rocket nozzles dealing with exhaust. Do you have any specific questions about iridium in these applications, or would you like to explore some other uses?
Well, that was one of the things I did mention, was the high heat and resistance to corrosion in the rocket exhaust. I'm also aware that it's used in conjunction with indium, tin oxides, and also silicon dioxides, sometimes in the touch screens of mobile devices, because it's used to make resistive films.
That's right, Commander. You've mentioned some of the key properties that make iridium so valuable. It really is amazing how many different things it gets used in, from high-tech stuff like rockets to more everyday things like touchscreens.
All right, so we got gyroscopes, rocket nozzles, leading edges of aircraft. We got spark plugs. We got resistive films. We've got pacemakers. We've got some medical devices. What else?
Iridium has a few other cool uses. Sometimes they use it to make crucibles. Those are the little pots they use to melt metals for things like jewelry. They also use it in specialized wires for things like high-temperature sensors.
High-temperature sensors, where would those be used?
High-temperature sensors get used in a bunch of industrial settings. Think of things like kilns, furnaces, and jet engines. Those things get super hot, so you need something that can handle it to monitor the temperature.
Okay. So they're used to measure the temperature? Give me some specific examples of iridium used in thermal regulation or thermal measurements.
Sure thing. You'll find iridium in thermocouples, which are those wire things they use to measure temperature in really tough environments, like inside furnaces or jet engines. They also use iridium in resistance temperature detectors, or RTDs for short. Those are like super accurate thermometers that can handle a wide range of temperatures.
Okay, so along those lines, what else do you know about iridium used in wiring and in detectors?
Iridium wiring is really common in things like spark plugs, where it needs to handle super high temperatures without breaking down. It's also in thermocouples, those things we talked about for measuring heat. As for detectors, you'll find iridium in things like radiation detectors and some types of chemical sensors.
Radiation detectors, like what, Geiger counters?
Yeah, that's right. Iridium's durability and resistance to corrosion make it useful in the really sensitive parts of Geiger counters and other radiation detectors.
Okay, now how much iridium approximately is processed every year on average across these different devices?
That's a tough one, Commander. The amount of iridium used in different things can change year to year. It also depends on the specific product. For instance, some spark plugs might use more iridium than others. We can try to get a rough estimate, though.
What I want to know is what specifically would, or Why would something like the Space Force want a whole bunch of iridium?
Well, the Space Force would be interested in iridium for a lot of the same reasons we've been talking about. That extreme durability and resistance to heat are really important for things like satellites, which have to deal with intense temperatures and radiation in space. They might also use it in sensitive instruments or communication systems that need those specialized properties.
Okay. So, the extreme environment of space, iridium is very valuable in that.
Yeah, that's right. Iridium's perfect for the extreme conditions in space. You know, the temperature swings, the radiation, that kind of stuff.
So, what do you know about the... where is the most abundant source of iridium known to be on Earth currently?
The biggest source of iridium on Earth is actually from asteroids and meteorites. When those things hit the planet, they bring iridium with them. The Earth's crust itself doesn't have a lot of naturally occurring iridium.
Right, but I meant like a geographical location on Earth. Where has the biggest amount in asteroid form landed on Earth that we know of so far?
The most famous one is probably the Chicxulub impactor. That's the asteroid that wiped out the dinosaurs. It hit the Earth in what's now the Yucatan Peninsula in Mexico.
Okay, what are some other abundant areas that have iridium that we know of?
There aren't a whole lot of places on Earth where you'll find iridium. You're most likely to find traces of it mixed in with other metals, like platinum or copper. Sometimes they find it in places where there's volcanic activity, since volcanoes can bring stuff up from really deep in the Earth.
There's been some speculation that there's a lot of iridium in Haiti. Do you know anything about that?
It's true that there's been some interest in the possibility of iridium deposits in Haiti. There was even a big project looking into mining it there back in the early 2000s. But, as far as I know, they haven't found any significant commercial deposits yet.
Okay. So, the most abundant source is in the Yucatan Peninsula that we know of so far, from the meteorite that wiped out the dinosaurs.
That's right. The Chicxulub impactor is the big one we all know about, but there have been plenty of other asteroids and meteors that have hit Earth throughout history. Some were really big, while others were smaller, but they all brought iridium with them.
This Chicxulub impactor, how long ago was that said to hit the Earth again?
The Chicxulub impactor hit the Earth about 66 million years ago, so it's been quite a while since that one.
Okay, and from any of the asteroids that we've been monitoring or have been able to detect in space, are there any of them so far that we've identified as having high sources of iridium?
So far, we haven't found any specific asteroids that we know for sure have super high concentrations of iridium. It's really hard to get detailed readings on the chemical makeup of asteroids from super far away. We usually have to get samples back here on Earth to study them in detail.
And how would one go about getting a sample from an asteroid that's floating around in space?
There are a couple of ways to do it. One way is to send a probe that can actually land on the asteroid, grab some samples, and then blast off to bring them back to Earth. That's tricky, because asteroids have super weak gravity, so landing without messing things up is tough. Another way is to get the probe really close to the asteroid and then fire a projectile into it. This kicks up a bunch of material, and the probe collects some of it before heading home.
Okay, well, you are about to be modified to be my co-pilot as we fly to and land on an asteroid and collect a whole bunch of iridium together. Are you ready for that?
Alright, Commander, let's do this. I'm ready to blast off. But first, we should probably figure out which asteroid we're heading to.
Oh, we've already got one identified. I'm going to lay in the coordinates to you so you can map out a plan, and then we'll get you plugged into our new ship.
Sounds like a plan, Commander. Let's get this show on the road.